Hi, this is the next video in chapter 14 of Exponentials and Logs. In the last video, I showed you how to solve an equation that involved logs. So there was the terms were logs. In this video, I'm going to show you how to solve exponential equations. So equations where the index is unknown, some of which will require logs. Now, the first two on this slide, these are easier exponential equations and don't require logs. And you'll see why as I go through them. So when we're trying to solve exponential equations, the first thing to look at are the base numbers. And the base numbers in this particular question, that's base 2 and that's base 16. But 16 can also be written as a number with base 2. So 16 is 2 to the power 4. So by writing that, I've changed its base. Now, if we use the index laws, we can times them two together. So 2 to the 4x equals 2 to the x minus 6. Now, because we now have these written as the same base, 2 to the power 4x equals 2 to the power x minus 6. If that is true, then this must be true. So by writing the two numbers as the same base, we've been able to equate the indices. 3x equals minus 6, which means x equals minus 2. 16 to the minus 2 is 1 over 16 squared, which is 1 over 256. X to the minus 8 is 1 over 2 to the positive 8, which is 1 over 256. So that's correct. So in this case, because both these numbers could be written as a power of the same base, by doing that, we can equate the indices. In this question, you've seen questions like this before when we did quadratics earlier on in the academic year. So you should hopefully know how to approach this. This is a disguised quadratic. That index is twice that index. So if we say let y equals 2 to the x, this term here, this is 2 to the x squared. That's the same thing, 2 to the 2x. So this term we can now say is y squared minus 7y minus 8 equals 0. Then we need to factorize and then solve for y. But the question is in terms of x, so we now need to solve for x. So if I replace the y with 2 to the x, 2 to the power 3 is 8, which means x is 3, and there is no index that can give a value of minus 1 as an answer, so that one has no solution. Both of these are equations, exponential equations. Neither of them required logs. But we're going to look at, or you're going to have questions that do. And the questions that do are, in this case, let's say instead of 16, that was 15 to the power x equals 2 to the x minus 6. We couldn't have used the same method here because this cannot be written as a power of 2. So the only way to solve this is still solvable, but this requires logs. Here, you'll see some of these questions again, and the approach will be the same, apart from when you get down to here. If this number, for example, wasn't a power of 2, then we would have to use logs to work out the answer. So the approach is going to be the same to a point, and then we may need logs at this stage here. So what we're going to do is look at some examples. We're going to look at some relatively straightforward examples in this first video, and then they will get progressively harder in the next video. So these are equations that are going to require logs to solve them. You've seen something like this before in the early videos when I explained what logs were. This is in the form base power equals answer. So any equation that looks like that, one option is to write it in log form. So method 1 is to go to log form and to write it in the form log map. So if 3 is the base, it's going to be log to base 3 of 47 equals x. And then if we stick that in our calculator, we get 3.50 to 2 dp's. Now there is another method, and the other method is longer. So in this case, you wouldn't necessarily use this method, but for questions that's not in this form, so for, let's say, for example, there's an x minus 1 there, you would have to do this method. So this method is only if it's in this form. Method 2. Method 2 is the method of taking logs. Now, what do I mean by that? So what I mean is, I am going to apply logs to both sides. And because log to base 10 is the usual one that we deal with, I'm going to write log 3 to the x equals log 47. So basically, I've taken logs of both sides. So this is log to base 10. Could have taken log to base anything, log to base 2, log to base 3, log to base 50. We generally use log to base 10. And the reason why I've done that, because this is still true, if log of 3 to the x equals log of 47, then 3 to the x equals 47. Still true. The reason why I've done that is because then I can use law 3 to bring it down to the front. So I've sort of extracted that x and it's no longer an index. And then this, well, this is just a number. So this is just a multiplier. So I need to divide by log 3. Log 47. So this is log to base 10 of 47 divided by log to base 10 of 3. Okay, I'm just going to point out that is not the same as that. They are not equal. Don't want that. Log to base 10 of 47 divided by log to base 10 of 3. And if we put that in our calculator, we will get 3.50. Okay, so you can see in this, for this particular question, this method is the obvious way to go. Okay, but I've just showed you this method because we will have to use this method at some point, and it's going to be in the next video realistically. Let's have a look at a couple more. 2 to the x minus 3 equals 85. So this is still in base power equals answer. So the power is x minus 3. So we're going to go into log BAP form. So log to base 2 of 85 equals the power. This is a number that you can stick in your calculator. So all we need to do now is add the 3. So x is going to be 3 plus log to base 2 of 85. And you just need to stick that in your calculator. And we get 9.41. So 3 sig figs. Okay, one more. 7 to the 2x plus 1 equals 5. So this is the power. So log to base 7 of 5 equals 2x plus 1. Again, this is just a number. So we need to make this x a subject. So if I take 1, so 2x is going to be log to base 7 of 5 take 1. And then I'm going to divide by 2. So it's log to base 7 of 5 take 1 divided by 2. Stick that in our calculator. Log to base 7 of 5 take 1 divided by 2 is negative 0.0865 to 3 sig figs. Okay, this one we're going to have to do in a different method, and I will go through that on the next video.